Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we'll be finishing chapter 4. Some of you are like, yes, finally we can finish this chapter. I know it's been a little bit challenging and dealing with inequalities can sometimes be a little tough. But if you'll remember some key things, I think that you'll be fine. One of those is they're not really that much different than an equality. If you'll just learn those little tiny things that are just a little bit different than an equality, you will do very well with solving inequalities. Now, in today's lesson, lesson 4.6, we're going to be on page number 148. So if you will, you can go ahead and look over there. And in today's lesson, we're going to be doing solving linear equation inequalities in two variables. So we have done the Cartesian plane, but we did it with an equal sign. This one, we're going to do the exact, it's exactly the same. There's just one little addition that we need to make. Just like some of the other ones where we had to graph them on a line graph, now we're going to graph them on a Cartesian plane graph with the x and the y axis, just like we did with the equations. But the only difference is now, when we're done with it, we have to, remember how we were shading the line? So whichever side the line was on, we would shade that, we would color that part in. We're going to do the same thing on the Cartesian plane, and we're going to shade one side of the line, okay? So that's really the only difference. There is one other minor little difference, and that is you'll see the dotted line. Okay, the dotted line means that it is not included in the solution. Remember when we had the number line and we would say, okay, we're going to leave an open dot if that's not included, like let's say it's on 5. 5 is our critical point. Well, we're going to circle the 5 because 5 is not included in the answer. Well, in this case, this piece of the line right here, this is not included in the answer. Because it's not included in the answer, we're going to put a dotted line. If it is less than or equal to, if it is part of the solution, then we would draw just a regular line. But if it's only greater than, or if it's only less than, then we would use the dotted line. Okay, so those are really the only two differences. We're going to use the dotted line for an open circle when it's not included. And then we're going to have to figure out which side of the line that we have to shade in, telling us which direction is included in the solution. All right, so let's go ahead and look down here and let's solve this one right here. So let's just pretend just for a second that this is an equal sign. Let's just leave everything else aside and let's just say y equals 2x minus 2. Let's just pretend like it says equals. We're going to come back to this at the end, but for right now, let's just use the equal sign, okay? So how would we solve this? Well, this is already in y equals mx plus b, isn't it? This is already in a format that we can graph. Here's y, here's our m, here's our x, and here's our b. What is, hopefully, I know it's a long time ago, it was a whole chapter ago, but what does the m and the b equal? Well, the m is the slope, so the m is 2, that's the slope, and then the b is negative 2. What is the b? The b is the y-intercept, where it crosses the y line. All right, so I'm just going to kind of just draw a rough Cartesian plane. I'm not going to take the time to put it on a fancy Cartesian plane. So all we have to do is take this right here and we have to graph that. This is our y-intercept, right? Okay, so this is our y line, this is our x line. So if you remember right, this is our y-intercept. What does that mean? It means where it crosses the y line. This crosses the y line. Let me change the color so you can see it a little better. This crosses the y line at negative 2. Okay, so at negative 2, we're going to put our point. Now we would just do our slope. What is our slope? We have to count up and over. And this is technically y over x, the change in y over the change in x. So I like to write my slope as 2 over 1. Okay, because we have, if there's ever a whole number, you still do have an x. A lot of students mess that up. Remember, if it doesn't have a denominator, the denominator is 1, not 0. So we do have to move over on the x line one spot. So I'll just put a couple more little hash marks on this so that we have places to count up from. Okay. So we're going to go up 2 and over 1 because the y is 2 and the x is 1. So we're going to go up 2 because it's positive. So we're going up 1, 2. That puts us right there in the center line. And then we're going to go over 1 to the right because it's also positive. So this is where our second point's going to go. Now we can draw our line. Okay. Now be careful though, because now we have to go back here before we draw our line, and we have to go back to the original question. The original question said that it is less than or equal to. And because it's equal to, our line is going to be a straight line. Okay, not dotted. It's going to actually be a real continuous line. And you can see this on page 149 in your book. I'm basically doing the same thing that they're doing. Now, the next question, the next part of the question is this: which side of the line satisfies, or which side should we shade? For example, should we shade this side or should we shade this side over here? Okay. And here's the way that I do that. I always pick a point, and the point that I like to pick is always 0, 0. Let me change the color one more time so that you can see that that's not an actual point on our graph. This is, I'm making up this point, so I'm putting a point right here. Why do I want to do that? Here's why. If that point works, if that point satisfies our equation, then we're going to shade this side of the line. If this side does not work, then we're going to shade this side of the line. Okay, hopefully that makes sense to you. This is our test point, just like we've been having test points. So I like to choose 0, 0. That's an easy test point, 0, 0. Okay, now sometimes the line runs directly through 0, 0, so you have to pick something else, but I like to pick 0, 0 if I can. So what I'm going to do is I'm going to come back up here to my original inequality, and I'm going to substitute x equals 0 and y equals 0 because that's my test point. Okay, so here we go. Let's try it. So y equals 0 is less than or equal to 2 times 0 minus 2. So 0 is less than or equal to 2 times 0 is 0 minus 2. 0 is less than or equal to negative 2. Now, once we finally get it to where we're done solving it, we ask the question, is that true? Is 0 less than or equal to negative 2? And it is not. So we come over here and we say, since this is not true, okay, this was not true, then this is the side that we shade. In other words, any point on that side of the line will work. And let me show you that that's true. Let's pick a different point over here, any point we want, and let's just verify that it works. So let's pick this point right here. What is this point? Well, it's 3 on the x and it's 0 on the y. So that's 3, 0. Let's go back to our original equation up here and let's try to plug in 3, 0. So 0 is our y, and then is greater than or equal to 2 times 3 minus 2. 0 is greater than or equal to 6 minus 2. 0 is, less than or equal to 4. Is 0 less than or equal to 4? Yes, it is. This side works. Any point you pick over on that side will satisfy the inequality. So that's the way that you test those points. You pick a point. Remember, I love picking 0, 0. That's the one that I like to use. And then if you want to, you can just test another point on the other side just to make sure that you're correct. You should not miss these because when you test these, it should tell you if you're right or wrong. Okay? Why did we use a solid line? Because it included the equals to. What if it did not include the equals? Then we would not have used the solid line. Go back and look in your book here. Let's turn to page number 150. And let's look at a couple other examples of this. If you have y is greater than or equal to -2, this one has no slope. This one, it has a y-intercept, but it has no slope. Notice y equals mx plus b. There's no x. So because of that, all we have is our y-intercept. It intercepts at -2. And it is also equal to, so that's going to be a solid line. We would test a point. If we test 0, 0, we would say 0 is greater than or equal to -2, and that is correct. So we would shade all of this stuff at the top. So if we go over here to this side, x is less than -2. Notice there is no y on this one. So we have our intercept, but this is an x-intercept right here. So it's intercepting the x-axis right here at -2. And so this would be a dotted line. Why is this line dotted and this line is a solid line? Because this one is just less than. This one is not equal to. And then we would test out our point. We can test 0, 0. So if we plug in 0, 0 is less than -2, and that is not correct. 0 is more than -2, and so we would shade this other side of the line. Okay? All right, so graphing a linear inequality in two variables. Step number 1. This is easy. 2 steps. Okay, you should be able to handle this. Graph the equation. I know it says graph the inequality, but graph it like it's an equation, okay? You graph it the same way we've been graphing in chapter number 3. Then you look back at the sign. Is it a solid line? Then it will have an equal sign with it. Is it a dashed line? Then it will not have the equal sign with it. Then we're going to, step number 2, we're going to test a point. Usually origin, what is that? 0, 0. That's the one I like to use. If it's true and that works, then you shade the side that 0, 0 is on. If it doesn't work, then you shade the other side. Okay? And then there's just some practice for you. So a little bit of a shorter lesson, but again, if algebra is crazy, right? You have to remember everything else that happens in algebra in order to do the current lesson. So this lesson is quote unquote easy if what? If you remember how to graph. So you got to go back into your bag of tricks, back into chapter 3, and dig out the graphing information, find it where it's at in your brain, figure it out, graph the thing. Then we have to use what we learned in chapter number 4. What is that? Well, the inequalities. So if it's part of the solution, then it gets a solid line. If it's not part of the solution, it gets the dotted line. Then you have to test a point. We've been doing all this all along in this chapter. So algebra is kind of a funny thing. It's not like you can just learn something and then forget it. You have to learn it and remember it because we continue to use it throughout the year. Okay? So if you're having trouble with this lesson, more than likely you're having trouble with the graphing lesson. So what I would suggest, if you're struggling there, go back into that video, watch that video again, and try to learn how to graph, especially from the y-intercept. Now, what happens if they don't give it to you in y-intercept? Well, you just put it into y-intercept. How do you do that? Go back to the graphing chapter. I'm not going to reteach that here. So you have to go back in the graphing chapter, watch that video again, and learn how to put it into y-intercept. Once you're into y-intercept, graph it, check the points, right? Dotted line, solid line, which side should I shade, do it, and then you'll get your solution. All right? That's all I've got for you. Hopefully you learned something there. If you missed it, slide it back or go back and watch the video that you missed from the graphing chapter. Hope you have a good one. We'll see you later. Bye bye.